Welcome students. This is Pankaj Singh, askIITians faculty working with askIITians since last 3 years, and today we are going to start a chapter surface chemistry. Okay, as the name suggests, surface chemistry. In this chapter we are going to discuss and study about the phenomena which take place on the surface of the molecules. We'll start with adsorption. We'll see what is the difference between adsorption and absorption, different type of adsorption, application of adsorption, adsorption isotherms. We'll see catalysis, enzyme, colloids, emulsion and many more. So let's start with the introduction to surface chemistry. Surface chemistry. Okay. So as the name suggests, in this chapter surface chemistry we are going to study about the phenomena which take place at the surface of any molecule or substance. So surface chemistry is basically study of the chemical phenomena that occurs at interface of the two phases, that means at surface, usually between a gas and solid or between liquid and a solid. So surface chemistry is basically related with all the chemical phenomena which take place at the interface or surface. And the most common phenomena which we are going to discuss in this chapter is adsorption. What is basically adsorption? So adsorption is the phenomena of attracting and retaining the molecules of a substance on the surface of a liquid or solid, resulting into a higher concentration of molecules on the surface. And the substance on which the substance adsorbed on the surface is called adsorbate, and the substance on which anything is adsorbed is called adsorbent, and the surface is called interface, like this. Let's say it is a surface, and let's say it is solid surface on which gas molecules are adsorbed. So these gas molecules are adsorbate, and the surface, the substance on whose surface adsorption is taking place is known as adsorbent. It is adsorbent, and this surface of interaction between these two is called interface. So what is basically adsorption? Adsorption is the phenomena of attracting any substance on the surface of another substance. Just like say we have a solid, let's say charcoal, and we know that it has an ability to attract or adsorb the gaseous molecules. So let's say carbon dioxide comes and gets accumulated on the surface of this charcoal. So we will say that adsorption is taking place because gaseous molecules are present on the surface of the solid but not in the bulk. Again one thing, molecules are only attached on the surface and not in the bulk. So the concentration of the adsorbent molecules are on the surface, and it is very low in the bulk. That means, again I am repeating, in adsorption is the process on which the molecules of substances are attached on the surface of any other substance, only on the surface and not in the bulk. So it is called adsorption. The substance which is adsorbed is called adsorbate. The substance on which adsorption takes place is called adsorbent, and the surface is called interface. Okay, when there is an increase of the concentration on the surface, it is called a positive adsorption, and if there is decrease in concentration, it is called negative adsorption or desorption. Just say like this: when molecules are attached on the surface, this attachment is called adsorption, and when the attached molecules are again released, it is called desorption. So these are the two opposite processes: process of attachment of molecules on the surface, adsorption or positive adsorption; the process of release of the molecules from the surface, negative adsorption or desorption. And adsorption, now there are two terms you must be aware of, that adsorption and absorption. We have studied that in case of adsorption, the molecules are attached on the surface only. But there is another situation which is called absorption. This is a phenomenon which is known as absorption, and in case of absorption, the molecules are attached not only on the surface but in the bulk also. They pass through the surface to the bulk. Just like we know a sponge absorbs the water molecule on its surface also and in its bulk also. So absorption and adsorption are the two different processes. In adsorption, the process of attachment takes place only on the surface and not in the bulk, while in case of absorption, the molecules are present throughout the bulk and on the surface also. So we can say that adsorption is a surface phenomena which takes place only on the surface, while absorption is related with whole mass of the adsorbent. In adsorption, the substance is only retained on the surface and does not go into the bulk, while in case of absorption, the substance is uniformly distributed throughout the body. Like this, you can say that this is the example of adsorption, on which this is adsorbent and this is adsorbate, which is present only on the surface. While in case of absorption, the molecules pass into the bulk. So this is absorption and this is adsorption. Okay, now there is another term, characteristics of adsorption. So the first characteristic is that adsorption refers to the existence of higher concentration of any particular compound at the surface of a liquid or solid phase than it's in the bulk. That means the concentration is higher on the bulk, on the surface and not in the bulk. So we can say that adsorption is a surface phenomena. Next is that it is specific and selective phenomena and depends on the physical and chemical nature of both adsorbent and adsorbate. That means it doesn't mean that anything can be adsorbed on the surface of any other thing. There is a special criteria. That means the adsorption is specific. Only particular type of adsorbates can be adsorbed on the surface of particular type of adsorbents. Next is, there is a special thing that easily liquefiable gases are adsorbed easily, and it is always exothermic in nature. The process of adsorption is exothermic. The process of attachments of gaseous or liquid molecules on the surface of solid molecules is exothermic in nature. That means enthalpy of adsorption is negative. Again, enthalpy of adsorption. The adsorption of a substance on the surface of another leads to existence of new type of forces between them. Therefore, it is an exothermic process and it is followed by release in energy. That means if we have a solid surface and if gases are being attached on its surface, that means adsorption is taking place, and so this process will always followed by release in energy because it is an exothermic process. Adsorption is always exothermic process. Some amount of energy is released when any substance is adsorbed on the surface of any other substance, and the amount of energy released is called enthalpy of adsorption. The enthalpy or heat of adsorption is defined as the heat energy evolved or released when 1 mole of adsorbate is adsorbent on the surface. 1 mole of adsorbate is adsorbed on the surface of adsorbent. Okay, now there are two types of adsorption actually. The first is physical adsorption and second one is chemical adsorption. Okay, now what is the difference between them? Let's have a look at the physical adsorption first. Adsorbate is adsorbed on the surface of adsorbent. Adsorbate and adsorbent molecules, they come together and they are just attached on the surface. Adsorbate attaches itself on the surface of adsorbent, and if this process does not involve any chemical reaction or does not involve formation of any chemical bond between adsorbent and adsorbate, there is only physical van der Waals attraction, then it is called physical adsorption. Weak van der Waals forces are present between adsorbate and adsorbent, and there is actually no chemical bond formed. And it depends on the nature of gas. Easily liquefiable gases are adsorbed easily. Next is Heat of adsorption is small for physical adsorption. It is only about 5 kilocalorie per mole. So heat of adsorption is small for physical adsorption, and it is reversible in nature. The molecules are attached on the surface because of physical attraction or van der Waals attraction. Heat is released, a very small amount of heat is released. If heat is supplied back to the subsystem, the molecules will again get detached from the surface and desorption take place. That means it is reversible in nature. It can be reversed again. And it forms multi-molecular layer. That means first of all, first layer is adsorbed, after that another layer is adsorbed, and another and another. That means multi-layers can be formed on the adsorbent surface, and it occurs at low temperature and decreases with increase in temperature. Why? Because we know adsorbed why it occurs at low temperature, because and again it decreases with increase in temperature. This is because we have studied that adsorption is an exothermic process. That means some amount of heat is released when adsorption takes place, and that is why whenever we increase that temperature, the rate of adsorption keeps on decreasing, because it is an exothermic process. Okay, and again increased pressure increases adsorption. What will happen if I increase the pressure? Let's say there are some gaseous molecule in the atmosphere, and if I increase the pressure, these will come together and will get attached to the surface of solid. That is why, and if the temperature is increased, they will go far from one another and they will never accumulate on the surface. That is why when temperature is increased, we can say that rate of adsorption decreases. When pressure is increased, rate of adsorption increases. Next type of adsorption is chemical adsorption, and this is a type of adsorption in which some chemical bonds are formed between adsorbent and adsorbate molecules. Let's say this is the surface, molecule comes together and there is formation of a chemical bond and satisfaction of valency, then it is called a chemical adsorption. Chemical bonds are formed between adsorbent and adsorbate molecules, and this is much more specific and depends upon the nature of both adsorbate and adsorbent. And heat of adsorption is high, 40 to 400 kilocalorie per mole, as compared to physical adsorption where it was only 5 kilocalorie per mole. And it is irreversible in nature. Once the adsorption took place, once the bond has been formed, it cannot be broken down again. That is why chemical adsorption is irreversible in nature. And next is, it forms unimolecular layer, because we know chemical adsorption is related to directly satisfaction of valency, and once the valency has been satisfied, no more molecules will be attracted toward itself, toward the surface. That is why one layer comes in contact with adsorbent, chemical bonds are formed, valency is satisfied. Now there is no need for the further reaction, so there is only one unimolecular layer formed in case of chemical adsorption, and it takes place at higher temperature. Now the question comes, why? It first increases with increasing temperature and then keeps on decreasing. That means whenever temperature is increased, first of all the rate of chemical adsorption increases, and after a certain time it starts decreasing. So the plot is something like this. Firstly rate increases and after that it starts decreasing. Question comes, why? We know that chemical adsorption involves formation of chemical bonds. That means it involves chemical reaction between adsorbent and adsorbate molecules, and every chemical reaction requires some amount of energy for starting the reaction, which is known as activation energy. And because of that activation energy, first we have to supply some amount of energy, and after that once the adsorption has been started, it will keep on decreasing because it is exothermic in nature after that. So we can say that this is activation energy. And high pressure is favorable, again just like previous one, high pressure is favorable and decrease of pressure does not cause any difference and does not cause desorption. Now factors affecting adsorption. First of all, temperature. We have just studied that adsorption is an exothermic process, so if we rise the temperature, the rate of adsorption will decrease. Pressure and concentration, again we have studied that greater the pressure, more would be the rate of adsorption, because molecules will come more close to the surface and they will get adsorbed. So it has been found that in most of the cases the adsorption is reversible, and an increase in pressure of gaseous vapor or an increase in concentration of the solute causes increase in adsorption. That means pressure is increased, adsorption increases. Nature of adsorbate and adsorbent. We have discussed that adsorption is specific in nature. Physical adsorption specific, chemical adsorption highly specific for the nature of adsorbate and adsorbent. So it has been observed that easily liquefiable gases are more readily adsorbed on the surface. Easily liquefiable gases such as ammonia, HCl, chlorine, sulfur dioxide, carbon dioxide, etc. are more readily adsorbed than the permanent gases which cannot easily be liquefied. And this is because that the molecules of the former type of gases have greater van der Waals or molecular force of attraction. Now there is a solved problem that which of the following statements regarding the physical adsorption of the gases on the surface of the solid is not correct. The first is, on increasing temperature adsorption increases continuously, and it is actually incorrect. We know adsorption is an exothermic process, so increasing temperature should decrease the rate of adsorption. A is the incorrect option, and for the question, correct option. Answer is A. Which of the following is not characteristic of chemosorption? It is irreversible. Yes, chemical adsorption is irreversible in nature. Once the adsorption has been taken place, the bonds has been formed, we cannot revert it back. There is no desorption for chemical adsorption. It is specific. Yes, it is highly specific. It is multi-layer phenomena. This is incorrect. This is chemical adsorption is a unilayer phenomena. Once one layer has been formed or the valencies has been satisfied, there will be no more adsorption taking place on the surface, and that is why only one layer is formed. So it is, yes, a unilayer phenomena and not multi-layer. So C is the answer here. So students, now we are aware of adsorption. We know what is difference between adsorption and absorption. We know that what are different type of adsorption, that means chemical adsorption, physical adsorption, what is the difference between these two, and we are aware of the term adsorption enthalpy or enthalpy of adsorption. In next video we will move to adsorption isotherms. Keep watching.